Hello. Okay, great. So I'm Shri Bhupathi. I'm the founder at Mill5, and I've worked at various markets, including capital markets, buy and sell side hedge funds, insurance, healthcare, and utilities. I've led several projects through Mill5 as well, and we're here to talk a little bit about enterprise in the AI. I'm sorry, AI in the enterprise.
Hey everyone, my name is Jorge Gonzalez, Senior Engineer at Mill5 with larger experience working in AI, machine learning, enterprise software projects.
Yeah. So a little bit about Mill5. We're a global consulting firm. We're in several locations in the US, Latin America, and Colombia, and Argentina, and in India. Our services go from software consulting that includes traditional software as well as AI and machine learning. We do performance engineering, which has to do with you got an application out there, how are you scaling, whether it's at the edge, in the cloud, on-prem, and we also do some managed services. From an industry perspective, we do financials, healthcare, manufacturing, consumer goods, retail, utilities, and energy as well. Before we get started with the meat, I wanted to kind of get a show of hands, if possible, on how many of you know DevOps? All right. How many of you know MLOps? All right. Put a few hands. So the next slide's actually something funny. This weekend I was looking at it. Everyone heard about the OpenAI GPT-3, kind of thing. I said, well, write me a limerick on AI, and this is what it showed. Which I thought was pretty cool. I don't know what the use case for GPT-3 is yet, right? Other than to maybe say, like make you chuckle quite a few times, right? But it's pretty cool. I think it's come a long way. But getting into the meat of things, this is what our agenda looks like. We're going to go through some of the challenges that exist right now that we see in the field with customers. We're going to talk a little bit about navigating those challenges. We're going to talk about the MLOps fabric, what it is, what it means. We're going to go through the summary. We're going to talk about where, you can see some of these demos. We've got a booth right down there, and you can actually get in touch with us to see some of these demos in action, right? So talking about these challenges, it's an alarming number. 80% of machine learning projects don't see the light of day, right? And this happens at various stages in the project. It happens from envisioning to maybe you're a quarter way through, maybe you're trying to discover what your data sources are and you realize that, hey, I don't have enough, right? All the way to, hey, I've got a model ready, but it's just too cumbersome to push into production. Or maybe your model runs at the edge, right? And how are you going to push it there, and how are you going to get it up and running? There's no coordination between IT and the development teams and the data scientists and such, and it just falls apart, right? This is a huge number. 80% is almost as bad as the number of software projects that don't see the light of day, which is not good, right? And some of the key factors when we deal with our clients and we're trying to solve their problems, some of the key factors that kind of surface up are business alignment, right? You've got SMEs who have KPIs that want, a certain problem to be fixed, but by the time the model is actually built, and rolled out, it's not really solving that particular problem. It's in the same zip code, but it's really not solving the particular problem that they're trying to solve. You got data issues, data is key, right? It's one of those things that, when you start to, you get your data engineers, engaged in the whole project, and they're trying to look at this data, and you realize that you really don't have the kind of data to solve the problem. And then you try to go and source it. And sourcing data is expensive. We've got clients who paid tens of millions of dollars to try and source data for their models, and they're still nowhere close to being done, right? It's a huge problem. And a lot of projects run into this, right? And you've got input drifts, customers change, your businesses change, your products evolve, your services evolve, and it's important to be able to capture that drift and bring it back into your model training process, which again, a lot of organizations don't have a way to do that, or they're doing it manually, which causes a lot of errors, a lot of pain, and so on, right? And then performance, it's not, model performance is important. That's one aspect of it. We're also talking about IT performance at this at this particular point, where if you've got your model that's running across the globe, right? You got a few GPUs, you've got some VMs that are provisioned across the globe. Now your application starts to kick in, right? The users who are actually starting to use this application and such, and your costs start to go up, right? Your models start to cost a lot more than was initially anticipated, right? So from an IT performance and from a model performance, it's not either or, it's actually both that need to be taken into account. Right? Process of moving into production. This is another thing that we see clients struggle with. I have a lot of smarts. I always say there's a lot of smarts created, especially in New York and finance. There are so many people who do great things, but they never see the light of day because they don't have a process in place to bring those smarts to production, get them either shadow tested, A/B tested, and then kind of funneled into, making a V2 of that product and moving it forward, right? A lot of people are still doing it manually, right? And it's impossible to scale like that. If you've got one or two models, it's okay to just, take your pickle file, move it there. Okay, great, I've got it up and running. But who's taking a look at it? What's your uptime look like? What does your performance look like? How many users are you hitting? What are your data drifts, right? It's a completely different process when you go from one or two to dozens or even hundreds of models, as your organization starts to warm up to using AI a lot more, right? And low transparency. We talk to a lot of our buy-side firms to say, well, we can't use these models because how are we going to go to our investors and say, well, the computer made the decision? Well, it shouldn't be that way, right? You should be in a position where you're able to explain why that decision was made, what did it take to actually train the model to do certain things and how you got to where you are. These are challenges that, are roadblocks at different stages, right? You might start off with a project at some point, but you start to hit some of these challenges and you're slowed down and then it starts to cost more and people start to ask questions, and all of those contribute to the 80% failure rate on ML projects, right? So how do you navigate these? The first one we suggest is getting buy-in from leadership. Your leadership needs to be able to back you on your projects. They need to be able to say, well, this is something that will work. And the way they can do that is by, you surfacing metrics or business surfacing metrics to show value, right? Efficiency that machine learning models can actually bring, the decision automation that is ubiquitous at this point, right? And how are you able to explain that? Adapting to change, how are you capturing those input drifts, and bringing it back to your data scientists and your data engineers to be able to reform your model, and bring a new version out quickly, right? Reach, chatbots, right? And the Alexas of the world. Do you have something that's exposed on Alexa? Do you have something that's exposed on the Google channels, right? To be able to bring that model down to the edge and being able to engage your customers. The reach is awesome, right? So you need to be able to show some of those and surface some of those pluses to your leadership to be able to back you there. And obviously, compliance and governance. If you're doing work in the European region, being able to show that your models are compliant with GDPR and the CCPA world, where you're not storing any of the PII stuff. It's important for leadership to understand where you are. It's important to understand that the models actually support it and to be able to back your efforts, right? That's where it all starts. Cultural shift. This is less of a problem now, but it used to be huge a couple of years ago where, businesses and teams wanted to develop products and start to push machine learning, but your organization as a whole hasn't made that cultural shift. People are still wondering, like, why am I doing this, right? I can write my if then else and then get my software to do this. Why am I using machine learning, right? So driving that cultural shift is super important. And create a process, right? There's, you usually see these silos in organizations where the business doesn't talk as much to the data scientists or the data engineers, who don't talk as much to software engineers, who don't talk as much to the IT organizations, or IT organizations start to become overbearing because they see that there's, history of these different business units not talking. That shouldn't be the case. If you have a process and everyone is in the know, it should just be simple. You put something in here, you have your data, you explain how you're picking your data up and you move that forward. This should just be, a rinse and repeat kind of a scenario, which we don't see a lot of organizations have, and they struggle. It's very expensive. Data scientists are not cheap. Data engineers are not cheap. It's hard to get someone in this market. For you to have a process just makes it easy and simple and allows your business to actually look at it and realize an ROI out of these investments in your data science projects, right? So what we're going to be talking about is MLOps particularly, and these are a couple of charts from Google Trend Searches. You'll actually see that about 2019, MLOps, which used to be called model ops at one point, started to tick up, right? And this is where, when we started Mill5, there was a lot of talk about, hey, how do I get my software out there? How do I get my models that are embedded in my software? Or how do I deploy them somewhere, right? Running on FPGAs or GPUs or whatever, right? Around 2019, you can actually see that machine learning had become almost mainstream. Almost every organization is using it in one way or another. And they started realizing, well, how do I move this forward? How do I hand this off to my IT team and say, well, guys, it's your headache now, right? I'm interested in the model performance and everything else. You guys take care of scalability, making sure that it's highly available across the globe, So they started looking at a process, and MLOps, you can see, actually started ticking up quite a bit and going, almost to 100% compared to model ops, right? The core of an MLOps team, right? It starts with the people. The core of the MLOps team is, these folks right here, right? It starts with the subject matter experts. These are the guys who have business KPIs, who understand the business KPIs, who know what they're supposed to deliver, and are able to translate it to the rest of the team. The data scientists, obviously, these are model builders, right? They understand not just your business, but they're also talking to the SMEs to understand exactly what nuances they're supposed to be looking out for. A lot of the organizations we've seen a dotted line between the SMEs and the data scientists, which is not good, right? Over communication is probably better in this scenario than under communication, between the data scientists, data engineers, and the SMEs, right? Data engineers, these are folks that have data skills. They know what to look at, where to look at stuff. Some of the data engineers, if you've got a consulting company engaged, they know where to source the data from. These are the guys who do your exploratory data analysis, the ELT, ETL jobs, and so on, and shape the data enough for your data scientists to basically pick this up and then start building their models. Software engineers, I always get asked about this question when we're pitching to clients, is why do I need software guys in here? How many of you have machine learning models in production right now? Couple. Are they running do they have any software around them? Yes, right? So when you have a machine learning model, you do have software engaged. And a lot, if you're not getting your software engineers engaged at an early stage, they're scratching their heads. They're wondering, what am I going to call into? How am I going to call this? What is gRPC, for crying out loud? What are you talking about, right? So these are the things that you need to have your software engineers understand while you're building your models, saying, hey, listen, what I need is a stream of data coming in this way. And what I'm going to give you is an inference or a prediction this way, right? This is how it's going to work. And sometimes it might be an asynchronous process, right? They need to understand how they're going to call into your services, what they're going to expect, how they're going to surface that data, and what value they need to record on their side, so business is able to look at the end of the day and say, well, okay, KPI, check, right? DevSecOps, these are guys who build your CI and CD pipelines, right? They've been doing this for years in the software world where, you check in a particular piece of software and your version control thing, it goes all the way into an integration environment. There are tests run against it, automated, hopefully, and then it gets propagated to your QA or your production systems, right? These are the folks who are going to now need to understand what your machine learning models in the field are going to look like. How are they going to be built? What are their dependencies? Are you going to deploy it in a container, or are you just going to take your pickle file and create a conda environment, put it there and say, thank you very much, start running, right? These are things that DevSecOps needs to understand. Also security. Well, how are you going to open it up? Do I need certain ports open? How is an application going to talk to you? These are things that they just need to understand, right? And unfortunately, in a lot of organizations right now, this conversation happens at a very late stage, right? It doesn't happen at the beginning or in the middle of your model development process. It happens all the way towards the end, and IT is not ready, your processes are not ready, and you're scratching your head wondering, I have a model, how do I get it into production? How do I get it used right now and get value out of this thing, right? Sorry, I don't know why this is, I think I'm going backwards. Sorry. Your machine learning and software architects. Another big one, right? Your machine learning architects are the ones who are going to set the stage for what architectures you're going to be using, what hardware are you going to be running on, right? What dependencies you should be taking. Like, there's CUDA 12 that's coming out very soon, after CUDA 11. We're going to be talking about it in tomorrow's talk a little bit more. But these are conversations and decisions that your machine learning architects are going to take and talk to your software architects. Because if you're running at the edge, you got a system in a data center, maybe at NYSE or at a hospital or whatever it is, you're going to be communicating with your software guys and saying, well, I've got software running here, I got my models running here, how are they going to talk? Here's my dependencies, here's how my updates are going to be applied to this as I keep building my model, because I don't want people going in there, plugging their USB ports and copying stuff over, right? So all those conversations need to be coordinated between machine learning architects and software architects, and obviously IT architects, right? Because they're the ones who understand, well, from a grand scheme of things, it's their neck on the line, right? When you've got 5 models running in your organization, the traditional, 10 years ago, before the cloud was even a thing, everyone said, well, I wanted to go buy a eight-way CPU, like a 4U that's sitting in the data center, right? And when you look at the applications being used, you're probably about a 30% utilization, right? It's expensive with GPUs, right? There are a lot of heat, a lot of power, and only so much space that you can put into a machine. So density is as important in the GPU world as it was in the traditional IT world. So engaging your IT architects will help them pick the right GPUs, line them up correctly, and leverage some of the newer technologies like multi-instance GPUing, which Jorge is going to be talking about tomorrow, HPC kind of stuff, on your existing application. So it's important to get them engaged in your conversations and building a model right from the beginning. Right? And then you've got the augmented team that goes in and out, right? You got legal. If you're doing something, legal wants to know, like, hey, what are you transferring? How are you transferring? What dependencies are you taking on it? Are they actually open source? If they're open source, can you use them commercially? These are sign-offs that legal's obviously going to be involved in, right? And you got compliance and governance, same thing, it could be, how is user data being transformed? Are you masking it before you make this decision? What are you storing, in your information? Hopefully it's not any PII, so on and so forth. And where are you storing your data? How are you transferring it? Even if you're running your model in Germany, for instance, it's not right for you to actually send back information out across certain boundaries, right? So keeping those in mind, you've got to build your model, and you got to get these teams kind of engaged in this conversation sooner than later. We talked about IT. I'm not going to repeat myself here, but IT is another one that comes in and out quite a bit. And support. You don't want to get 2 a.m. calls on why your model's not working anymore or why it's down, right? You want to make sure your support groups are aware of what you're running, what their line of action is if something goes down, right? You need to have those runbooks ready and stuff. And it goes back to dealing with DevOps and such to create those runbooks to make sure IT actually knows and support actually knows what to do if things go wrong. The next slide, is about data, and I'm going to have Jorge, kind of take it away for the next couple of slides. Oh, I'm sorry. I was going to talk about data. Sorry, my bad. So data is obviously a huge aspect of it, right? Sorry. So it's not just about accessing data. It's not just about gathering data. When you're building your model, if you're in a regulated industry, someone's going to knock on your door and say, well, you're being audited on why certain decisions were taken. And you better have information on why you chose a certain set of machine learning data for training. How did you shape it? How did you shape it, and so on and so forth, right? So the data selection process is super important, and MLOps needs to cover data selection, EDA, which is exploratory data analysis, the feature engineering process, and so on. All of these things need to be just captured. It's not easy to version some of these processes as it is software, but your tool needs to be able to do this, right? And give you statistical summaries, right? What's my missing data? Do I need to create synthetic data? How many, what's the count of rows that I'm working on, and so on and so forth, right? And creation of synthetic data. We had clients where we had to create synthetic data using, for machine vision models using Unity, right? So how are you going to create the synthetic data? How much are you creating? All of this stuff is something that you need to cover in a machine learning process.
Thank you, Shri. Okay, from the training perspective, you know that the training is the most compute-intensive step on machine learning. So here you need to take into account that it is the best way to deploy our infrastructure is be able to deploy and tear down all the infrastructure in a repeatable manner. This is our most hard requirement here. Also, those compute resources should be IT compliant. That means that needs to meet the organization requirements and policies. Here, the IT department should provide the guidelines to do that, to deploy that hardware in our environments. We also need to consider budget considerations, budget restrictions, sorry. So here, the machine learning engineers, as Shri said before, will be able to provide us, for example, infrastructure as code templates with cost in mind, security in mind, and be able to deploy those resources easily. Repeatability is a very important feature for our data scientists. So the organization should provide the right tools to allow them to retrain, to prepare their models, to evaluate and deploy those models in a confidence way, with confidence. From the experiment perspective, you may know that maybe if you have 1 or 2 models, be able to versioning or track the experiments on them will be a trivial task. But what happens if you have 5, 10, 50, 100 models? That will be a little bit tricky to track or version them. So here, it is very important to provide the tools that allow the data scientists to track those versions, track the experiments, track the model parameters, be able to also track the code of the experiments. And for example, if they have 5, 6 experiments, and after the 6th experiment, they realize that the third one was the one that they get, where they get the best performance, how can they go back? So we need to provide them with the right tools to go back, use the same data that they use in training and things like that. There are regulated industries, so it's important here to be able to track choices and decisions. You need to have the option to, for example, record partial dependence plots, Shapley values, things like that. And for further analysis, this is very important. At the end, when your experiments run successfully, you will want to optimize and register those models. That means that you need to make sure that your model is able to run on the intended hardware. If you want to run on the edge, you have limited resources, limited memory, limited compute. So you need to maybe optimize that model to be able to run on that kind of environments. So all this means that your model is ready for production. Shri is going to talk about that more in detail.
So I think we're almost run out of time, right?
So yeah, if there are any questions, or I don't know if this thing is on. Yes, it is.
Yeah.
So thank you very much.
You're welcome.
Unfortunately, we're at the top of the hour, and we have our panel coming up next. But we have contact information here, and if there are any deep dive questions you'd like to ask, please see the presenters afterwards.
Absolutely.
Thank you.
All right, cheers.